Hi everyone, my name is Chris Hale. I'm a product specialist at Chauvet Professional, and today I'd like to take the opportunity to talk to you about how a moving head actually works and the mechanics actually behind it, whilst I'm in my improv home studio here while we're on isolation. So the fixture I'm using here is the sort of top tier product, our Maverick MK3 profile. It has an 820 watt white LED engine, full CMY colour mixing system plus a variable CTO. It's got a 1:9 zoom ratio, so we've got an incredible 6 degrees to 54 degrees, plus we also have a full shutter framing system. So as far as complexity is involved, this is a really good fixture for me to actually explain the mechanics of actually how a moving head works. Right, for me to go any further really, I've got to remove the covers. Now it'd be pretty boring for you to sit there watching me remove the covers, so we're going to speed this bit up. And there we have it, the actual fixture is now stripped down so we can actually start talking about all the internal components. Right, it makes sense to actually start from the base of the fixture. So the first component I'm actually looking at is the switch mode power supply. Now the switch mode power supply itself will auto range in voltage between 100 volts and up to 240 volts, and will auto switch between 50 to 60 hertz. Now it'll do this automatically, so if you've got a tool that's going out and it's going between different countries, then you haven't got to worry about adjusting the power supply. Now before that, we actually have wire wound transformers, and you have to re-tap the transformer depending on the voltage you're using or the frequency you're using. And if this was done incorrectly, then you had a high chance of the power supply or the fixture actually exploding. Okay, I've spun the fixture around just so we can see the back of the fixture here. So along with our switch mode power supply, we've also got a power supply that supplies the LED engine. We've got our DMX inputs, and along with that we've got inputs for SACN and ArtNet, as well as WDMX. Now these signals are fed directly to our main PCB, of which then it's decoded and used to control the various attributes within the fixture. Right, moving on, we've got our yoke. So this allows us to pan and to tilt the head. So in the base of the head here we've got our LED engine. So this is obviously liquid cooled as well as fan cooled. And then moving up we've got our CMY colour mixing system with our variable CTO. We've also got a direct access colour wheel, a full animation system, a high CRI flag, we've got rotating indexable gobos, and then we've got our full framing shutter module here, that's also rotatable, an iris. We've got 2 prisms and 2 frosts. So there's a lot of attributes within a small area. But we've also then got our zoom and our focus modules that are here. So this allows us for this much movement. So it gives us that 1:9 zoom ratio that I was mentioning earlier. So we've got our 6 to 54 degrees of zoom. These attributes, the majority of them are actually controlled by step motors. Now the step motors themselves are actually driven with these drivers, and that's going through using something called CAN bus technology. So all you have is basically voltage and serial data. So you end up with a small connector like this that would actually drive a lot of step motors within a module. Now before CAN bus was used, we used to have either 4 or 6 cables going to each step motor that would actually have to run back down onto the motherboard. And traditionally this would cause issues with cable breaks and things. So having CAN bus is a huge leap forward for us. So we've said that the attribute is controlled by stepper motors. So the fixture itself needs to know where every attribute is. And the way we do this, we mainly use 4 different types of sensing technology or indexing, of which I'm going to run through all of them. So basically you've got mechanical, you've got magnetic, you've then got electrical, and you've also got feedback. So the first of which is the mechanical indexing. Now this is used on the animation wheel position, the actual framing shutters, the iris, the zoom, and also the focus. So you may have noticed when you first turn a fixture on, it may make a slight clicking noise. This is because the stepper motors themselves have been told to do a certain amount of revolutions. So it will actually push these attributes to their physical end stops. so that the fixture then just assumes that they're at their end stop. So this is the most simple form of indexing that we actually do, or we actually use. So next up we have magnetic indexing, or the use of a Hall effect sensor. So what this is, in short, is when a magnet is held underneath the sensor. It's very much like actually turning a switch on. So we would use these on any effect that is continuously rotating. So for instance, on here, we're using it on the static colour wheel so that we know where the open position is. And the same with the rotating gobos, so we know where the open position is on them, but along with also the rotation of the gobo itself, so the index position. On this particular fixture, we're using it for sensing obviously the pan and tilt positions, or the end stop positions, along with the position of the prisms and also the frost. So when you first turn the fixture on, these attributes will actually move to their positions, and as soon as the magnet is actually underneath the sensor, that tells the fixture where its home position is. So next up we have electrical indexing. So this is basically the use of a micro switch. So on our CMY module here, what we do is when the fixture is first powered on, the stepper motors will be active and it will drive the colour flags out to their home positions, so that when the micro switches are actually activated, that's the home position. Now this is a very simple form of sensing, but very, very reliable. And finally we have feedback sensors. So on this particular fixture, we're actually using sensors that are actually monitoring the pole. So if I was to accidentally push this fixture, it would actually be able to detect the movement of the poles, or magnetic poles, and actually feed back to its start position. So that's one way of monitoring the feedback. Also, you can actually use optical sensors. So you'd use two optical sensors that would count the steps where the fixture was accidentally moved, and it would feed back to the original position. And that's it. Hopefully I've given you a bit more of an insight into how moving light works. So all I can say now is stay safe.